This lesson is the second in a series that helps you understand relations and functions. A relation is a well-defined relationship between a set of input values called a domain and a set of output values called the range. This lesson describes two-dimensional relations represented by a set of ordered pairs. They're ordered pairs because the order matters. The first element of the pair is the input x value, called the independent variable. The second element of the pair is the output y value, called the dependent variable. The y variable is called the dependent variable because its value depends on the independent x variable. The set of all input x values is the domain of the relation, and the set of all output y values is the range of the relation. It's useful to think of a relation as a machine with an internal mechanism that relates an input x to an output y. For this relation, the internal mechanism is the set of ordered pairs that define the relation. The inputs to the machine are the elements of the domain, and the outputs from the machine are the elements of the range. For example, if you input x equals 4, the output is y equals 2. If you input x equals 8, the output is y equals 4. Notice that if you input x equals 3, the output is not defined, since x equals 3 is not in the domain of the relation. The relation is not defined for values of x that are not in the domain. A relation can also be represented by a mapping diagram. In this diagram, the domain is shown on the left, and the range is shown on the right, with arrows to define how an input value of x relates to an output value of y. For example, the ordered pair 4, 2 is represented by an arrow from x equals 4 to y equals 2. A mapping diagram makes it easy to show when a relation is a function. When the elements of the domain map to only one element in the range, the relation is a function. It's very important to understand when a relation is a function. This relation is also a function, but it can be a little confusing because two elements in the domain map to only one element in the range. It's still a function because 1 maps to only 2, and 3 maps to only 2. That they both map to the same element doesn't matter. A relation is not a function when elements of the domain map to more than one element in the range. For this example, the element 3 in the domain maps to two elements in the range. It's very important to understand when a relation is not a function. A relation can also be represented by a graph, where the points on the graph show how input values of x relate to output values of y. For example, the point 6, 3 defines a relationship between x equals 6 and y equals 3. A graph also makes it easy to see when a relation is or is not a function using the vertical line test. If a vertical line can be drawn anywhere that intersects the graph of the relation more than once, the relation is not a function. For this example, in addition to x equals 4, this relation fails the vertical line test at x equals 2 and x equals 6. You can see from the graph of this relation that it is a function. No matter where you draw a vertical line, it intersects the graph only once and passes the vertical line test. This relation is a function. The relations used in this lesson are discrete relations. Discrete means that each point on the graph of the relation is not connected with the other points. The relation includes only the points that are shown and not any points in between. The next lesson describes continuous relations and functions.